In this video, we will discuss how the global stability of a segmentation solution can be assessed by running repeated calculations of segmentation solutions on slightly different samples. Global stability analysis is a way to learn about the structure of a dataset. It helps us to assess data structure, to use the most appropriate market segmentation concept, and to select the most suitable number of market segments to extract. Global stability analysis can be used for both distance and model-based segment extraction techniques because it is independent of the algorithm used to arrive at a market segmentation solution. The idea is very simple. We use slightly different subsamples of the data. This part is based on bootstrapping, and then calculate a number of different segmentation solutions. We then compare the resulting solutions. Optimally, we want to see the same solutions re-emerge. But that does not always happen because consumer data rarely contains distinct, well-separated segments. In the worst-case scenario, data can be totally unstructured. Unfortunately, it is not known in advance what the structure of any given empirical dataset is. Global stability analysis can help us make an informed guess. We distinguish three prototypical cases. Case 1 is that of naturally existing distinct and well-separated market segments. The figure you see here illustrates such a case. We have three very distinct market segments. They are well separated because no people are located between the segments. We refer to this case as natural market segmentation. Natural market segments are easy to find by most extraction methods and, importantly, the same solution emerges if the calculation is repeated. Natural market segmentation solutions are very stable. As such, they can be safely used as the basis of long-term strategic planning and the development of a customized marketing mix. Natural segmentation is the best-case scenario when we run market segmentation analysis. The worst-case scenario is the case we refer to as constructive segmentation. Here, the data is entirely unstructured, making it impossible to reproduce any market segmentation solution across repeated calculations. Every new calculation will impose a different algorithm-induced segment structure on the data. Stability is very low. In this worst-case scenario, the data analyst must help the organization to construct managerially useful market segments. These segments do not naturally exist in the data. They are artificially created. The challenge, therefore, is not identifying them, but selecting, of the many possible solutions, the one that is managerially most useful. This process requires management and data analysts to work together very closely. The middle ground between these two extremes is when consumer data lacks naturally distinct clusters, but is not totally unstructured either. We refer to this case as reproducible segmentation. Looking at this picture, for example, we can see that technically the data contains only one segment which has an elliptical shape. Such a segment is not managerially useful because the consumers on the top right end of the segment have very different product requirements than those at the bottom left end. But we can leverage this data structure to extract segments which are artificially created but re-emerge across repeated calculations. So market segments resulting from reproducible segmentation are artificially created but are relatively stable. If we have a new data set and we want to conduct market segmentation analysis, we need to know in which of the three cases we are operating. Global stability analysis can help us with that. We conduct it before we extract segments. It helps us to determine if we can conduct natural or reproducible segmentation, or if we find ourselves in the difficult position of having totally unstructured data, forcing us to creating artificial segments. It also helps us to decide how many market segments we should extract from the data. How do we conduct global stability analysis? First, we need to draw from the consumer dataset a number of samples which are slightly different. We do this because we know that the sample we have is not a perfect reflection of the actual consumers, so we basically put a bit of noise back into the data. We can do this using bootstrapping. Based on our experience, drawing about 100 pairs of bootstrap samples works well. Next, we extract market segments from each one of those datasets. Then we calculate for each pair of bootstrap samples and segmentation solutions the adjusted RAND index. We have discussed this index when we talked about cluster indices. The adjusted RAND index tells us how similar the segmentation solutions are. We then plot all the adjusted RAND indices for all bootstrap samples across all number of clusters and inspect those plots. The inspection of the plots provides insight into how stable segmentation solutions are for this dataset. This in turn determines if we need to run natural segmentation, reproducible segmentation, or constructive segmentation. Finally, we can choose on the basis of this plot which number of market segments to extract. Let's have a look at one of those global stability plots. The plot is a parallel box plot. It shows us for each number of segments extracted the distribution of the adjusted RAND index over 100 pairs of bootstrap samples. The horizontal line in the middle of the box is the median value, and at least 50% of all the adjusted RAND indices lie within the box. What we want to see is a high median value and a narrow box, because this tells us that we can consistently achieve high stability across replications. In the plot we see here, stability is very high for the two-segment solution. This is frequently the case because the segmentation may just distinguish between respondents who agree with most survey questions and those who disagree. But the four-segment solution also emerges as relatively stable, with both the three and the five-segment solutions being much less stable. In such a case, we would probably inspect the two and the four-segment solutions in more detail. This plot is also indicative of reproducible clustering, because there is no single solution with exceptionally high stability as compared to the other solutions, which is how natural segmentation would manifest in this plot. But on the other hand, stability is also not terribly low for all segment numbers, which is what we would expect to see for the constructive market segmentation case. So, analyzing the global stability of the empirical consumer dataset at hand is a useful approach to data structure analysis because it provides key insights into the data, which determine how to best extract market segments from this data. And with R, it's really easy to do because the bootstrapping and repeated extractions of market segments can be automated. Global stability analysis is a simple step we can take to prevent running market segmentation analysis blindly without knowing what is going on in the data.